Hello, my CNC brother or sister. I'm Garrett with IDC Woodcraft, the company that you get your CNC router bits from. If you have a Longmill CNC router, an MK1 or an MK2, and you want to upgrade it to a Spindle to get rid of that noisy trim router that you have on it, then in this video, I'm going to walk you through the process of how to install a Spindle on your Longmill machine, where you don't need a whole lot of technical knowledge. idcwoodcraft.com. When you upgrade your CNC router to a Spindle, whether you're doing a Onefinity, Longmill, Millright, Shapeoko, there's several things you're going to have to get. And first of all is, of course, the Spindle kit. Now, we have PwnCNC, which is the company that has actually built a plug-and-play device for these various machines. I will link this information down below in the description, and also links to PWN so you can see exactly what they have and what you want for your machine, but I'll give you more description down below. But of course you need the Spindle, which they will provide, and the control and the various elements that's going to make your Spindle work on your CNC router. And then you're going to need bracket hardware that's going to mount the Spindle. In some cases, like in mine with the Longmill MK2, they have come up with a very nice upgrade to the Spindle mount that is currently on the machine. So that's what you need to make sure that you need to get these plates, and then of course the other various hardware. And the next thing you're going to get is new drag chain. Now, you will only need this new drag chain if you are getting the water-cooled Spindle. So this is a larger drag chain than you will find on your benchtop CNC routers. And that's because we need to run water lines through the drag chain for the water-cooled Spindle that I'm using, which is what I recommend. The water-cooled Spindles, they last longer. It's a few more components, but they last longer and they're much, much quieter than the air-cooled Spindles. So you'll want to get the drag chain. Of course, I'll have that linked down below. And if you're getting the water-cooled Spindle, which I again recommend, you're going to need to get the water pump, which comes from PwnCNC, the hose, and you want to make sure you have the flexible hose. Again, I'll link that down below. And then we're going to need to get a bucket, and I'm going to use a 5-gallon bucket. I'm going to use windshield washer fluid for mine. Now, this is recommended after doing quite a bit of research. And the reason we're using that is because we want to protect our equipment against freezing. Some people put water in a water-cooled Spindle, but the problem is if your shop gets below freezing, that water's going to freeze, and when water freezes, it expands. And I can guarantee you that as robust and heavy as this Spindle body is, that expanding water will not stop. It can literally crack that housing and ruin that Spindle. So we're going to go with this. I've already researched it, we're okay. And then we need grommets here that are going to basically seal the bucket. We're going to stick the tube through the grommet, and so there's going to be 2 hoses going in here. The pump is going to be inside the bucket. Now, one other thing you're going to want to have is if you get the water cooled, where you need other things to turn on when the machine turns on, meaning when you hit the go button, you want this water pump to turn on. So the other thing you're going to need to get is what's called an IoT relay. And this is connected to your control for your CNC router. And what that's going to do is when a signal gets sent, it's going to engage this IoT relay at the same time it starts your G-code program. And that's going to send power to this, which will turn everything on that you have hooked up to it. You're going to have lights and your water pump and what have you. So those are the things that you're going to need. Again, I'm going to list them all down below. And in order to accommodate the water lines, because I'm using a water-cooled Spindle, I have to install new and wider drag chains. So I had to pick 3 of these up from Amazon. If you're upgrading to a Spindle, this is one of the things that you're going to need to get. Now, this is the original drag chain. This is the wider version. And if we take a look at, it's over here. And before I even do anything further, I'm going to pop open all these gates, and then we'll bring it around and connect it here. Okay. I can't lay them back in until, let's see, so this needs to go around to here. So we can see that this here is the motor for the Xcarve, and that needs to be exposed, so I know that I have this much too many links on this, so I'm going to have to knock some of these links off. Just like that. All right, and now what I need to do is lay the water lines through here so I can work with them later on. And it's time to run all our wires. At this point, I'm getting ready to run the wire for the spindle control to the spindle. So one of the things you want to make sure of is the connectors themselves are running the right way. Now, if you look at the connector, you can see there's a male version and a female version. So we want to just double check which side is going to go out to the spindle on the Z carriage. So when you look at your spindle, we're going to see that this is the male here, 4-prong, and we got a 4-prong male here. Just double check, make sure that it plugs in properly. And it is keyed, so it can only go in one way. And so we're just going to spin it around, and there it is. So this is the spindle side. This side is going to go through the drag chain out to the spindle. For now. One of the things about adding this bigger drag chain to the Z carriage and everything is you're going to have to drill a couple holes into it to make it fit, because at least in the long mill, the bracket slot goes that way. This is the MK1, and so I had to drill an extra hole right in the bracket here. I need to move it down because if you look around here, right there, this wire right there was actually dragging on the chain, and so I had to move the whole drag chain down so it wasn't rubbing the wire to the motor. These brackets right here are actually going to get in the way. These are the brackets that came with the long mill, these little type brackets that hold the drag chain, and so we're going to have to remove them and leave them off permanently. The drag chain will support itself, so I'm okay with that, and if not, then I'll come up with an alternate bracket. So we're taking these guys off, and now the drag chain, you can see, is supporting itself for the most part. I may come up with a bracket to hold it, but now we're just going to move the carriage all the way down, make sure this drag chain doesn't bind anywhere. That's what I'm looking for. So we're good that way, and we're going to come back the other way. Oops, there we go. And of course we're watching all our wires to make sure they don't hang up on anything as we're doing it. And the drag chain is doing quite well all the way down. Nothing is hanging up, but I do have to put a new bracket on for the drag chain because you can see the weight of it is pulling it down. Not a big deal. I'll figure it out. The way that I have secured this drag chain is very simple. I had this self-drilling screw. It's just sitting in my toolbox, and I just ran it down into the drag chain right there, drilled right into it and right into the frame of the long mill, and that now makes the drag chain very secure. The one thing you just want to make sure is when you do that, that you know where this drag chain is going to lift up at when it's all the way over, because you don't want to screw it in at a point where it's going to try to lift up when the whole carriage is moving over. So move it all the way over here. You'll get your mark, your area where you want to drill it through. Use one of these screws. You can buy them at any hardware store. I'll link it down below. And then you'll know how to secure your drag chain. Now I had to stop putting the machine together because I made an error. I thought I had ordered the 65 millimeter spindle, which is a 1.5 kilowatt spindle for my long mill, but I had actually ordered the 80. And when I ordered the mounting bracket with it, I had ordered the 65 millimeter mounting bracket. So you can see here the size of the hole relative to the size of the spindle is definitely the wrong size. So I had to get the right one for the 80 diameter unit. But this just sends home a point that when you're ordering all these components, the spindle, the mounting bracket, the hose and what have you, the drag chain, that there's quite a few things to take into account. So again, down below in the description, there is a PDF of everything you want to take into consideration when you're buying your spindle and which ones you want for which machine. For example, if you have the Onefinity, the Millright, the Shapeoko, the Longmill, just make sure you get that PDF when you decide to get your spindle. So I'm going to just replace this bracket, and then we're going to mount the spindle on here, and then we're going to plumb things up and move on. Now, one of the important things is to make sure you don't tighten all the screws down just yet. We just want them to be just touching before they clamp. And we don't want to clamp this down until we get the spindle in here on this side where we have the split, because this is where it's going to actually clamp down onto the spindle from this side. So now it's time to put the spindle on. This is where we're getting really, really close, but we still have quite a bit to do. Anyway, I want to make sure that the PWN is facing forward. It's just a cool logo that they engraved on the spindle. So it does drop right in. I am going to tighten these two screws down. The reason I was waiting to tighten everything down is because I want this bracket to be sitting parallel with this bracket here. So I want the screws, the housing to rest on the screws, and then I'm going to, oh, grab the wrong wrench, I'm going to just snug that one in place, and I'm going to snug this one in place. Then we're going to give it a little bit of a tightening. I'm not going to over tighten because we are working with aluminum plates here, and we can strip that out if we go too much. Now, before I move on, there's one other thing I want you to be aware of. Spindles have more weight than the trim routers, like the Makita here. Substantially more weight. And some CNC routers, when the machine is actually doing the carving and it sets its height, the motors that are driving your different axes may shut off. It's not uncommon for that to happen, meaning no more power is going to the motor. When we have this much weight on the machine, that can cause some drift because there's nothing holding the motor in place. So once we have everything set up, we're going to go into our control software, and I'm going to tell you what code you need to enter into it so that when the machine stops and the Z axis finds its position, it'll stop moving the motor, but the motor will have power to it, holding the motor in place so that the weight of the spindle doesn't force it to drift over time. It's a very important thing that we want to take into consideration, whether you have a 65 millimeter spindle or the 80 millimeter spindle. All right, we're going to put this guy in, and the way I'm going to set this is I've got this little step here, and for now, that's where it's going to be. That step is going to be at the bottom of this bracket. Just like that. I'm going to hold it with my hand, orient my pawn, the PWN symbol forward, and so we've got quite a bit of weight on here, so you just want to be careful. Don't get your fingers underneath while you're doing this, because if you drop it, you have several pounds that's going to drop right on your finger, and it's going to hurt, and it could break a bone. When it comes to clamping around a diameter, when you have the full circle clamping on it, that's the absolute strongest way that something can actually clamp onto a round object. So we don't need to have a lot of force. There is a ton of grip that is going on right now. All right, so the next thing we're going to do is we are going to start plumbing everything up. Now, one of the things I would maybe not recommend is closing up the drag chain before you get things wired up. The one thing you want to make sure of is when your spindle is all the way up, you have enough wire that it's not going to start pulling on your drag chain. Same with the hoses. We've got the spindle all hooked up now, and all the wires and hoses are run through the gantry, the drag chain. Next is to mount the VFD, or variable frequency drive. This is the brains to the spindle. This is what controls it. But there are a couple other things we have to do. We have to wire this up to the control of the long mill, and we also have to run the plumbing to its source, where the water is going to come from to cool the spindle. But I've got a little bit of a problem before I start that, and that is over here on this side of the machine. I've got a mess of wires. I had them all bundled up nice and neatly, but we've got a whole bunch more wires. So what I'm going to do is really just get this off the top of the table. We're going to just do a little cutout here below the control so I can run wires down, and then we're going to come back up right here around the drag chain where all the wires go in, and then I will get to getting the VFD set up. But one of the things I want you to think about with your VFD is where you want to mount it. Now, some people I've seen, they'll mount it underneath the machine, which to me is inconvenient because you're going to have to reach down and read the little gauge there and turn it on and off. I'm going to mount it on the side of the table, right near all my other controls that are running the CNC, my stop button, where all the power switches are, all that stuff. I want it convenient to me, but also out of the way of the motion of the machine. So we'll get to that. We're going to get this wiring straightened up. And we are done. After about maybe 45 minutes, I got everything rerouted, just cut a couple holes in the table, just took all the wires underneath. I still have to bundle them up down here, but you can see my whole work area is clear. There's nothing that's going to catch up in the wires. And now we are going to work on getting the water pump hooked up. It's going to be very quick. And then we are going to get the VFD mounted. I'm going to make a table extension right here. It depends on what space I have right here. I may just mount it right here on the table. We'll see in just a little bit. We're going to take care of the plumbing first. In order to hook up the coolant, you're going to need some accessories. And we're going to run through them here, what you're going to get from PwnCNC and what you need to get. So if you come forward, first thing we're going to do, this is going to be very basic. We are going to use a 5-gallon bucket. I just purchased a bucket from Lowe's, and you want to have a top to the bucket. The next thing you're going to need is the fluid. Now I'm using windshield washer fluid. I have done a little research on that, and this stuff is going to be very adequate for what we're doing. From PWN, you'll need the water pump. And with the water pump, you're going to get a brass fitting, you'll get this plastic fitting, you'll get the plastic feet for the pump. And this is a submersible pump, so it's going to actually sit in the bottom of the bucket here. The next thing you're going to need are some grommets. Now this is the grommet that you want. Again, everything I'm listing here, it'll be in the PDF down in the description. You want to get that PDF and download it so you know everything you need to get, whether you get a water-cooled spindle or an air-cooled spindle. So this is the packet you need to get, and in that packet you're going to have these sets of grommets. We're going to use the second to smallest because that is what's going to fit on the hose, just like that. Now what we're going to do is we are going to drill holes in the top of the bucket lid, and we're going to insert the grommets here, and we'll bring the 2 water lines through the bucket, and then one of them will be hooked up to this brass fitting, which will be connected to the water pump. That will be the outbound, and then the other hose line will just go right in the bucket. It's going to be just open, and that will be the return line. Now, one thing, we are not going to use this bigger fitting. We're going to use the little brass fitting that came with it. And I don't think we need this, but I'm going to do it anyway, is use Teflon tape on the brass fitting. This is something you can pick up at any hardware store. Again, this will be on the PDF as well. The PDF has all the links that you'll need so that you can just order everything online. You don't have to travel to the hardware store. And when you use the Teflon tape, just wrap a couple times around, and then you can just screw that right into the top of the pump. And it does feel like that is something that we need. As a matter of fact, I need a couple more wraps on that because that thread was too loose inside that thread on the pump. So I'm going to wrap it around a couple more times. And what this does, this just helps to seal the, keep any water from coming out between these two threads and just going right back into the bucket. We want all the water pressure to go into the little hole there. So I'm going to run that in now, and that feels a little bit better. It's going down properly. It feels snug. That means that the threads are gripping, and I'm just going to take my wrench and just give it a little snug. This is a plastic housing, so we got to be careful. We just want things to be tight enough that it's holding. And we're set like that. So now I'm going to drill 3 holes in this lid. The first 2 are going to be for the grommet, and I'll just make them next to each other anywhere. And then on the opposite side, I have to drill 1.25 inches in order to fit this plug up through this lid and out to its power source. So when you're drilling holes on something like this, as you know, it can grab. So we're just going to put it down here on this piece of MDF, and I am simply going to step on it and drill anywhere in there. Now for the plug, this is all I have, is a 1.25 inch spade, and it's not a very good spade to be using on this plastic, but it's what I have, and we make do with what we have. So I'm just going to go on the other side, and we're going to and there we are. When we're inserting our grommets, really they're very easy. All you have to do is simply start it, squeeze it into that slot all the way around, and then just work it in until everything sits in right. And there we go. Give it a little spin. That grommet's in. You take the next one and get it in. Now when I insert the grommet, the hole is going to be a little bit smaller to insert the hose, but that's okay. We're just going to have to work with what we have. That one's there. I'm going to give it a little spin just to get that grommet to seat, both of them. And the trick is, can I use the grommets in here? No, not really. So we can go, I probably drilled that a little bit big. Maybe I would try 1 inch first and then go to the bigger size if we need to. So we've got that ready. That's just going to need to go in there. We need to get the water lines hooked up. Now my water lines are going through the table, so I'm going to run this down through the table just like that and do it from below. This time I won't be so assertive as I'm pulling it through, and I'm going to support the grommet. For the Waterline connector, this is a 2-piece thing that you're going to get, and what this is, it's a quick disconnect. You'll insert the water line into a little knurled fitting underneath this nut, and then you'll screw this ferrule nut down over the water line, and it'll actually clamp down on the water line. And then when you're ready, you just push that down and it's locked in. And if you need to remove it, you simply pull up and it comes off. And you see there's no drips coming off. These types of fittings are designed to have absolutely no drip. So that's a very nice type of fitting here. And hopefully I'm going to be able to get this pump to stick to the bottom. Not that it matters, but we're just going to wet the sucker's fingers, but we'll go with it. And it's stuck. Good. Now I'm keeping the hose lines separate from all my other wires that are hanging down because I just want to keep everything organized as much as possible. I want to make sure that the hose is in there enough, which I am very comfortable with. So I'm going to take one hose and hook it right to the brass fitting. Just like that. Now, on the spindle, there's not an inbound and an outbound circuit on that side on the spindle, so I'm not really worried which one I plug in, but if it's wrong, if there's some kind of problem, I have those quick disconnects. I can switch them real quick on the spindle. One of the things about those disconnects on the spindle is they don't leak. When you pop that off, you won't get any drips. They're designed to have no leaks. So we're going to bring that cord through and we'll go about like that. I'm going to pull this back. I don't want the hose to spiral around too much in there, not that it really matters. And we're going to fill this up with the coolant now. And then we're going to test and make sure everything works. That's the way I get that aluminum popped off. So and we're going to do this before we put power to the machine. So we're going to make sure I unpower the machine, but we're going to power the pump. And the reason I'm going to do that is because if we have leaks going all over the place, I don't want to get a short right away. And if I don't have enough coolant here, I've got 2 gallons. I can just add some water to it. It'll reduce the freezing point or increase the freezing point. Now is the moment of reckoning. Everything's unplugged except for the pump, which I'm going to plug in right now. So come on in close so you can see the water coming out from the brass fitting, and let's see what happens. There it goes. Come on up to the spindle. Take the spindle. Come up to the spindle. Okay, now we're going to let that run for a little while, let the air bubbles work out of it, and we're going to monitor for leaks. And also, I want to make sure there's volume of water being taken up in the hoses all the way through the circuit. So I want to make sure that the pump doesn't go below water level. It doesn't pull up so much water into the hoses that we lose submersion on the pump. I'm going to add another gallon of water to this because I want to make sure our pump stays below any evaporation over time that might work its way out of this hole, but I'll seal this hole. That way evaporation won't really happen. Now that we've got the water hooked up and working, the next is getting the VFD or the variable frequency drive mounted and secured. One of the first things is to not just set this thing on the table somewhere where it can vibrate off and fall on the floor. PWN is providing 2 different ways for you to mount your VFD. The first one, if you come in the back, is something they call a French cleat. Now they're going to give you this plate right here, and you can see on the plate it's got a little bit of an angle on it on the top. This plate's going to mount against a flat surface, perhaps here, and you'll hook it right onto the machine right there, and that will hold it actually quite securely. French cleat mounting is a very common way and a very strong way to hang things, signs that you might make, or it's used all over the place. Anyway, that's a French cleat. The other way is these brackets that they send with the unit, and if you come in close, you can see there's 3 holes in the bracket, 1, 2, 3, and it matches up with the holes in the panel for the control. for the VFD, and same thing on the other side. You have the same thing. And then you can just bolt this against whatever you're going to do. So what I'm going to do is my VFD, this is actually not a bad spot to have it right there. So I'm going to make a back plate that will come up at an angle here, and then I'll either use a French cleat or I'll use these brackets. I'll probably use a French cleat because with the French cleat I can just lift this off and move. So what we're going to do is we're going to install this little flow meter. And I will put a link for this down below. It's about $20 and super simple, super fast to install. So here's what we're going to do. We're going to take this flow meter right out of the package, and how this works is coolant flows through it and that little blue thing spins. Just like that. And so when your coolant is flowing through the line, that little blue thing will be spinning. You'll know that the coolant is running. So here's how we're going to set this up. Well, first of all, we're going to kill the power to the machine because we're going to be cutting into the water lines. So I'm simply going to reach over and cut the power off the machine. And now we're going to use a little rag just to keep any coolant that might drip out from getting on my spoil board and on my machine. I've got a couple of vice grips. You can use whatever you want, as long as you don't grip so hard that you bust into the line. There we go. And then I'll get my side cutters and cut the hose. And we'll take the flow meter, just insert it right into the, whatever you call these little barbs. And give it a nice good push so it doesn't come off. Release the vice grips. Clean up any water drips. Turn the power back on. And we're going to turn it on. And now we have water flow. And that's it. That's simple. You want to make sure that that water pump is running, because you can overheat your water-cooled spindle because it does not have airflow going through it to cool it off. I'm going to link this flow meter down below. It's like $20 off of Amazon. I suggest you get one. That'll confirm that your water pump is running for your spindle. idcwoodcraft.com. At this point, we've done quite a bit of work to get the spindle installed on the Longmill MK2. And the stuff that I've been showing you, if you don't have a Longmill, you have another CNC router, you can follow along for the most part with this stuff. All the principles on this are pretty much the same. So if you feel like I'm helping you and this spindle transition that you may be doing from a trim router to a spindle, which I highly recommend, then give me a thumbs up down below. And if you feel like I've missed something, you got some questions, of course, down in the comments, leave that question and I'll answer that. One of the other things that I just want to share with you is one of the things that you want to do as a CNC creator. When we're creating our projects, we do a lot of setup on our project. I mean, you can't run it without setting it up. The problem is setup steps. When you're setting your CNC project up, there are specific steps that you have to do. And when you have a broken bit right in the middle of a project, or the carve gets ruined, or the project moves, it's usually because you missed a step during the setup. And that's why I came up with the CNC project setup checklist. Now, what this checklist does is basically like a pilot's checklist before he takes your airplane up into the air to make sure that plane is going to fly safely. A checklist makes sure that your project is going to carve exactly as you expect without having problems. There's quite a few steps on here, as you can see. These are all the things we actually do every single time you do a setup on your CNC router. And I've seen more router bits break and projects get ruined because someone just missed a step during the setup. And that's why I created this. So from IDC Woodcraft, this is available to you for free. I'm going to link this checklist down below in the description of this video. I suggest that you get this and use this every time from now on to before you start doing your carves, because this will save you a lot of problem and unexpected errors on your project. This works. Get it. It'll be linked down below. So we're going to get back to the spindle installation. So I have made a bracket for the VFD, and I'm taking advantage of the French cleat as opposed to the hard mounting brackets. You can see I just made this little frame here. Just come on around and see how I've got that built. And it's just screwed down to the table. Screwed the French cleat to this upright, and we are simply going to hang it. And what I've done is, just in case, just throw a little screw on the top here that will hold that in place so it doesn't vibrate off, but it's quick to remove if I need to. And I'll watch my finger. That's all I need. And at this point, I can't take that off. It can wobble around. If it's an issue, I'll just change the way I've got it set up. At this point, we have to get the VFD connected to the Longmill. So here's what you are going to need for your machine, whether you're doing a Longmill, Onefinity, the Millright, or Shapeoko, or whatever other machines they have. Again, I'll list all that information down in the description. But we're going to need the power cord for the VFD, which is a regular 110 cord. We have this cable here, which is going to connect into your control box on your CNC router. So in this case, we have the Longmill control, and we're going to use this connector right here. It says Spindle, and we're going to have a little adapter here as well that we're going to use. And then finally, we have our little instructions that we need to follow in order to just wire this up properly. So if we come into this instruction here, when we look at this wire, we've got 2, 4, 6, 7, 1, 2, 3, 4, 5, 6, 7 wires. They are telling us to use the black and the red, and we wanted to pay attention to the configuration or the orientation of how that's going into the connector. I'm going to pull the connector, which is this one right here, and we're looking at it like that. So the red is going to go in on this side, the black is going to go on this side. You'll know because the connector cannot plug into the control box on the Longmill that way. It only goes in that way. And then the rest of the wires, the white, yellow, green, orange, and the ground are all going to be covered up. So I'm just going to pull those back, and I'm going to just tape them back to the wire. We're going to connect it to that, and then this is going to plug into this little box. Now this is the interface. This is the magic tool that PwnCNC has put together for your machine. That's why when you buy your spindle, you're going to designate which machine you are buying it for, so they know which control to put in. All right, I'm going to put this thing together, and then we're going to turn it on. Now we're going to put the wires into the connector that goes into the Longmill connector, and again, we're going to orient it the proper way. I know that this is the top, and you'll know it's the top because it can't fit in that way where the screws are exposed. So we're going to turn it that way, and we're going to line it. We have the red that goes in on one side, and the black goes in on the other. Once you have those all the way in, simply spin it over and start to tighten down one of the screws. So now we have the wire connected, and you'll always want to double check when you have to do the wiring against your instructions to make sure that you have wired things up properly, and I have. So this will connect into the spindle outlet on the Longmill, which is this prong, the one below the white one, for this particular control board. We're going to bring it up from the bottom, and I'm going to plug her in. And what I'm going to do is I am going to secure all these wires with zip ties when I'm done, because that can easily pull out. Any one of these wires can pull out with enough force. Now, we're going to take this control, this little transfer control, and I'm going to plug it into the only one that'll plug into. If we look over here, we can see there's 1, 2, 3, 4 different connectors. This one has 1, 2, 3, 4, 5, 6 prongs in it, and there's only one connector here that has 6 prongs in it. So that is the one it's going to be. We're just going to spin it around until it fits in the right way. There it is, and it should slip right in, and then we're going to turn the little locking screw. Now, one of the things I didn't think about when I was setting this up was this hanging out the side. So I'm going to have to come up with some way to simply secure it to the side of the machine or on the control box so that it doesn't get hit. I may have to move this control box. Get the other end of the connector, and for now I am simply going to connect it up to this box. So this is going to the control, the Longmill control, and we're simply going to do the same thing. We're going to put it on there and turn it until it drops in, and now we are connected. And finally, we simply need to get the power cord and get that plugged in. The power cord goes on the other side, and that is going to drop right down into the hole that I made there, and it'll go to my power supply. For now, I've got this power strip sitting here temporarily. I have another power strip coming that I can actually bolt to the table, so I'll link that down below too. I suggest that you do that because you're going to have multiple things plugged in this whole setup. It's kind of tight in here. I have to make sure that the wire, the routing of the wire does not come across the motion of the machine, so there's no abrasion going on. I'm likely going to have to move this box around. I'm upside down. Finally, we have to connect the spindle itself to the box so we can test it from that point on. So let's just get that connected. I'm going to bring that up the side as well. And this is a 4-prong connector, and we are looking for this one right here. I'm just going to bring it in, and then we're going to turn that until it drops in. There it is. And now we're going to turn the power onto the spindle. Now you'll notice on the VFD, this switch here, it's not an on-off switch. This is whether it's going to be running auto or manual. And what that means is auto is if you're running a G code, it will work through the G code. Manual is you have to turn the spindle on manually. So if I'm on manual just to test the spindle out, just come on over here and we can push the button and the spindle will turn on. And then we can, so the spindle is turning on, and we can adjust this little knob to the spindle speed that we want. If you switch it to auto, the spindle just turned off because there is no G-code command that had it turned on. So when you're running a G-code, you want to make sure this is always in auto. Otherwise, the machine will start to run, the spindle won't turn on, and you'll break a router bit. And we're going to hit the on button. And if we look over at the spindle is now turning. Now, I want to give you an idea of how quiet this is. I'm holding the microphone right next to it while I'm talking. 1, 2, 3, 4, 5. When you first test a spindle, you want to make sure it's turning in the right direction. And when you first run a G-code to it and it turns it on, you want to make sure that that G-code is turning it on in the right direction. So you're going to run a little test program without a project on your machine. So at this point, looks like we've got everything running. There's one more thing we have to do, and that is we need to connect our IoT relay. The IoT relay is going to connect to the VFD through this guy right here. And what this does is when the code gets sent to this box to turn the spindle on, it's also going to send a signal to the IoT which is going to send power to these 4 outlets here. So we're going to have a separate power supply plugged in right here, and that's going to go to our main power strip. And it's going to trigger a relay, and when those relays get triggered, these 4 ports will turn on. And one of those ports is going to turn on the water pump at the same time. And when the signal gets sent by the G-code to turn the VFD off, the water pump will also turn off. So we've got 4 different accessories we can plug into this thing that we will want to turn on when it starts to run. Maybe you want to put a little LED light on it, so the LED light turns on when you start to run it. So we're going to connect this up real quick, and we're going to test it with the water pump as well. For the sake of time, I have shortcutted just a little bit where I have mounted my IoT switch here. I'm going to move it to a different location. I still have to bundle up all my wires, but for the sake of this video, this is pretty much done. I want to show you how the IoT is set up. So if you'll come on down here. On the IoT, we have 2 outlets. These are normally on, and then when power is sent to this device, these will turn off. These 2 are normally off, so when power is sent to the device, it'll turn on. So the IoT has a plug. It's plugged into a temporary power strip, and here it is connected directly to the VF, the variable frequency drive. Now, one of the things you want to make sure of when you're connecting the IoT, there's a negative and a positive here, and there's a negative and a positive here. So you just want to make sure you align them properly. It's listed here what side is negative and positive, and on here it is also listed which side is negative and positive. It's printed right on there. So white wire, I've got the white wire on my negative, and I've made sure I did the white wire negative over here. Now here's how this works. The pump is now plugged in, and when I turn the spindle on, the water pump's going to turn on. So if we simply hit the green button, and we're going to turn the spindle up a little bit to some speed that's going to be about 8,500. The spindle is on, and the water pump has kicked on. I can see a few bubbles running through there. And when I turn the spindle off, using the little red button on the control, that's going to turn off, and the IoT switch is turned off, and the water is no longer pumping. One more thing we have to do is tell the control software, in my case it's G-Center, we have to tell it that there is a spindle attached to the machine now. Now, PwnCNC has given the instructions as to what you need to set in the software, in case you don't know. So based on this document, we are going to go into the firmware of G-Center. And this is specifically what they're showing here is the G-Center, because this is for the Longmill. For your unit, they're going to show you what you need. In the G-Center control software, we're going to go to firmware. Now we're going to make sure the settings are set right. And we bring up this screen. Now we're looking for number 30, 31, and 32. So we'll scroll down, and 30 is maximum spindle speed. On the sheet here it says 2400. So we're going to just simply change that number to 2400 RPM. And then the next one, minimum spindle speed is 0. And the laser mode enabled as spindle, that's disabled. We're set there. So at that point we are set. We're going to reset that right there. And so the EEPROM value reset. Single reprom, we're going to say yes, and that is set. And so now that's taken care of. Now it's just a matter of designing, just running a little simple program, make sure everything works right. Now there's one other thing that we have to take into account here. We've added weight to our Z-axis, and when you do that, depending on how your CNC router is set up, that may pose a problem later on, but there is a way to fix that, and it's very easy. So that problem is we have added weight, and as your machine is cutting, that weight can actually make the Z carriage drift down if your stepper motors are not in their holding mode. In other words, when the Z carriage is moving up and down based on what the G code is telling it to do, and it stops, then the motors will shut off. There will be no power to them. And as it's making a cut, it can actually vibrate just slightly in the machine, and that can cause, the weight can just cause the whole spindle to drift downward. So we want to turn on the motor locking function so that when the motors stop, there's still power to them, and that will literally hold them in place. So what I mean, if you come up here, right now I am just going to turn that shaft, and I can turn it easily, and the spindle is going down. It goes down a lot easier than it goes up because of the weight. So we're going to go back into the firmware on G-Sender, and we are going to go to step idle delay. And you should have a number of 100 in there. We're going to change that number to 255. You can see right here, it says, change the value to 255. It keeps the motors enabled with no delay. And so what that means is there's going to be power held to it. So I typed in 255. I'm clicking off on the side. And then down here it says to apply the settings. We're going to apply the settings. And now we have 255 here. Currently, that has not changed anything here. We have to now jog the motors, and that will lock the motors in, and they will start. So I'm going to move it up a little bit. I'm going to jog it up, and now I cannot turn this motor. The motor is now locked on, and all the other motors are locked as well. So they'll turn, but they're holding power to it, and you can hear it. I can hear a little bit of a hum, which is telling me the motors are being held, which is exactly what we want, and that'll take care of that problem. Now I have written a temporary quick program so that I know that the spindle's going to turn on when the G code turns on, or when I tell G-Sender or whatever control software you're using to start the program. Now, before we actually start, we do have to do one more thing. And I want to just clarify this little switch right here. You notice here it says auto, and on the other side it says man. Now, what that means is you can turn the spindle on manually, or you can have it turned on automatically, and automatically is through the G code. You want to make sure that that's turned to auto, so that when you start the machine, the spindle will turn on when the G code tells it to. If you have it on manual, the spindle will not turn on. So we want to come in close to this control here. And the first thing you want to do is hit the green button right there. And we are on auto. So now we are ready for this spindle to turn on with the G code. And we're simply going to run this simple little zigzag that I have built up right here. The machine's there, it's going to come over and do this. The spindle should turn on as soon as it hits that line, which is one of the first lines in the code. So you can bring the camera up here close, right to the spindle, and basically I am simply going to start the sequence. And you can see the spindle has now turned on, and it is quite quiet. Now we got a piece hanging down here, which I need to get up here. This is the proximity sensor, which I will wire up later. At this point, we have installed everything we need to do, and we know the spindle's running. There's two more things you have to do. Number one is tram the spindle so that the spindle is perpendicular to the machine. And the second thing is you have to set up what they call a dwell command. A dwell command actually pauses the machine before it starts to actually go into carving, because you got to give the spindle a little time to wind up. The spindle itself does not just start it right up to speed like your trim routers do. It takes about 3 or 4 seconds for it to get up to speed. So we have to put in a pause command in our G code. Now I've got a video that explains exactly how to set that up, so I'm not going to do that in this video. What I'm going to do is put a flag right here, or right here in the video. It's going to pop out, and that flag will lead you to that video, but I'm also going to link it at the end of this video so you can go straight to that, and it's going to be down in the description. So we're going to get into this tramming process, which is very important. That's making sure the machine is totally perpendicular, because if you don't have that, you're going to start having steps in your projects. So let's get on to the tramming part of this. So we're going to get into the tramming of the machine here, of the spindle relative to the spoil board. There's multiple ways to tram your machine, but tramming is vital, because if you don't do it, and the spindle this is exaggerated, is tilted like that, and it makes cuts, it's going to leave funny cuts in your project. So we got to get it perfect. So if you come here, like I said, there are many ways to tram, but I'm using what's called a tramming bar that I whipped up. And what we have is just a piece of wood about 3/4 inches, maybe an inch wide, and 3/4 of an inch thick. And I have 2 1/4-inch pins on each side of it. So what we're going to do is, in the spindle here, I'm just going to insert one side of that into the spindle. I'm going to butt it all the way up, and then we're going to simply just snug it up. It doesn't have to be real tight. It just needs to be tight enough that this does not move. Just like that. Now remember, these screws are still loose. The screws that are holding the plate to the bearings. So what I'm going to do first of all is just snug those screws down. And just give it a little bit of a turn until they're just lightly seated. I'm going to do 2 of the screws on each side. I'm not tightening them up because we still need to move this. Now you can see this spindle is moving. And now I want that to be a little tighter than what I've got it. So we're going to snug up a little bit more on the screws, because I don't want it to slip once I have everything tightened down. Now I've done 2, and I'm just twisting it again, and it's quite a bit tighter. So now I'm going to snug up the other 4 screws on the bearings. And now what we're going to do with this tramming bar, we're going to use this, we're going to spin it around 180 degrees on that direction, and then we're going to spin it 180 degrees in this direction. And what we're looking for is this pin here is going to be very close to the spoil board, and then when we swing it around, that gap should be the same over here. Now, to give you an idea, this is about 11 inches apart as far as where one pin is to the other pin. So when we swing that around, that's 22 inches. When we get that almost perfect, then we are going to be very, very, very close to our perpendicularity, and we will be good to go. So what I'm going to do is I'm going to bring this pin down close to the spoil board. And we want to be careful. We don't want to go fast like I just went. And I have to put my glasses on to see this because I wanted to get it a little bit closer. So now I'm set on the slowest speed, and that's what I want. It's not touching. So now we're going to swing it around 180 degrees, and I'm just checking for touch. Now, right now, it's coming over the edge. I don't want that, so I'm going to move the whole gantry back to about the middle of the machine. Right there. Now we can check everything and see. We can just eyeball first. Like I said, this is a very homegrown way of tramming your machine. If you want to get really, really close and tight and see exactly what those numbers are, then you can use an indicator or a dial gauge. I'll link some tramming bars down below in the description, but you want to make sure you've got the clearance for these particular gauges or indicators as well. So this is just the quick way that you can do this if you don't want to go out and buy another gauge. So now we're doing pretty good there. And over here, it's just starting to touch. So I'm going to push it back just a little bit. And it's probably going to touch over here. All right, it's just starting to touch right there. And it's touching right here. So my side to side now is good. I'm very happy with this. This is going to work out very well when it comes to CNC routing. So I'm going to come in and I'm going to start to just lightly snug up each one of these bolts, and I'm going to go back and forth, and I'm not tightening it all the way, just enough. And we're just going to check again to see if things have moved. And it just stops right here, and it stops It's going a little bit past. Now, there could be some deviation in my spoil board, but it is very slightly past that swing, that 180 degrees. And again, we're 22 inches apart. This is a really, really tight, for CNC routers, it's a very close tram. The tram for the left and right, or X, is set. Now we have to fix the Y because it is out. And when it comes to CNC routers and tramming front to back, unfortunately, it's not so much fun, and this is across the board for all CNC routers. We have to shim things. So we come in here, and we look at this tramming bar. We're at the back, and I've got, I'm not sure what kind of gap I have. I'm not seeing it all the way, but if I swing around, it stops, which is telling me the tram is out. Now I can give it a good push and start to get some forward movement on it just a little bit, but that's not the way we want to do it. What we have to do, if you come over here, is because what I'm seeing here, the back end of the tramming bar is not touching the spoil board and the front is. That means that the tram of this router is leaning forward. So the tram of the router is leaning like this. And that means I have to shim the bottom of this bar here to help it swing back out. And this can be a little bit of a guessing game, but what I will use for shim is a piece of regular paper. And I'll loosen these bolts up, and then we will slip a piece of paper in the bottom here, and then I'll tighten it back down, and we will recheck the tram. The unfortunate part is when I loosen these bolts, it could throw my X tram, or this side-to-side tram, off a little bit. It's just part of getting our machines tuned up in the way we want to go. So I am going to loosen these bolts up. So I've put something under here just simply to support the weight, because once I loosen these screws, the whole spindle's going to drop. It'll bend my little tramming bar here. So I'm just going to have to do it like this. This is one of those things that's going to forces us to be a little creative. So what I'm doing is I'm taking this paper now, and I am simply pushing it up in the bottom there. So it's on both sides. It's coming up and it's touching this screw head right there. And that's my stop point. So we're going to tighten everything down again. Spindle and everything. And we want to get tight. So I'm going to do the two bottom ones first, because I'm going to clamp evenly on the paper, and then we'll do the top ones, and what that will do, that will pull it up. We've set everything up for the spindle for the PWN kit. You know everything that you need to add to your machine, particularly if you have the long mill, but it'll also give you ideas on your art machine. If you do not have a long mill, you have another type of machine. Again, remember, the PWN spindle is available as a kit. It's basically plug and play. It's going to take a little bit of time to get it installed, but other than that, it's it's one hell of a nice little tool upgrade for your CNC router. There is one more thing to do, and before you get to that, I just want to remind you, down in the description are links for the PDF that has all the stuff that you'll need to get for your spindle upgrade kit, and videos that I've mentioned and other things. Just make sure you take a look at the description. The last thing you need to do is set up a dwell cycle for this so that your spindle has time to ramp up to speed. Otherwise, it'll start carving before it gets up to its proper speed. Now, I'm going to save that for another video, which I've already created, and that's linked right here in this video. You just hit this, or again, that'll be down in the description. So I strongly recommend you upgrade to a spindle, because a spindle is designed to have the long-term runs that we need out of our CNC routers. The little trim routers aren't, they burn out a lot. So the link for the spindle, this PWN spindle kit, is down below. If this video is helpful, please take a minute to give me a like and a comment down below, things I might have missed or other tips and tricks for other creators who are thinking about upgrading to a spindle, something that you have done to your CNC router as you upgraded to your spindle. I do recommend water-cooled because it is the quietest of the two options. The other option is an air-cooled, and air moving through something makes a lot of noise. So the water-cooled, very pleased with how quiet this spindle is, and of all the things that I am enjoying about this spindle is the peace and quiet that I have rather than a screaming router. Links down below. Have a great day, better tomorrow, and happy CNCing. idcwoodcraft.com